All right, so now for 48, the information given is -2 with multiplicity 2, and they also give you 4 with multiplicity 1, and they tell you it's a third degree polynomial. So the first thing we do is, because of the -2, we automatically put x plus 2, and then because of the multiplicity 2, we put 2 there, and then because of the 4, we put x minus 4, and then you could raise it to the first power, but we don't usually write that. To double check, you'd say 2 plus 1 does give you 3 for your degree. Now, the reason why we're adding our exponents is because we're multiplying. We're doing x plus 2 squared times x minus 4. So that's why we end up adding our exponents. So here I just rewrote what it looked like, and I expanded the first term. If you want to skip a couple of those steps and then write this one, you can. Like if you want to go straight from here to here, that's okay. So basically x plus 2 squared turns into x squared plus 4x plus 4. And then after that, it's not really FOIL, it's just multiply it out or distribute. I did x squared times these two terms, and then I did 4x times those two terms, and 4 times those two terms. And then combine your like terms. So we end up with a final answer of x cubed minus 12x minus 16. X cubed minus 12x minus 16. Any questions? Okay, then 52. This one, the difference is there's a 2 in front of it. We've got 2 times the quantity x minus 3 times x squared plus 4 to the third power. And you basically want to write all your characteristics about it. There's 4 steps. It says list each real 0 in the multiplicity. So the real 0 is 3 with multiplicity 1. You can't say -4 with multiplicity 3 because that's not real. Okay, that'd be imaginary. So it's just that front part. And then we interpret it. We know that if it's multiplicity 1, then it's going to cross. It's not going to bounce or touch. So the graph crosses at x equal 3. And your maximum number of turning points, what you do, or what I did to start with, is you see your x squared raised to the third power. So I just took out all the numbers and I just said x and then x squared to the third power. So that turns into x times x to the 6th, which is x to the 7th. And then for your number of turning points, it's always 1 less than your degree. And so that gives you 6. So even though nowhere up here did it say 7 or 6, you've got to work it out to figure out your degree and your turning points. And you don't have to write this stuff to the side. I put optional aside. I put x squared plus 4 equals 0. It's -4. Square root of -4. It's imaginary. In fact, that would be 2i, but you don't need to put that. The power function. Okay, so this is probably the first time we're talking about the power function. The part that students miss sometimes is they forget the number 2 that was in front, or whatever coefficient was in front of everything. You have to put that, and then you put your degree, which was 7, so 2x to the 7th. So you basically simplify it to the 2, and then your answer for this part, x to the 7th. So you basically need your leading coefficient with your power. Let's actually see what that looks like on the calculator. So let's see, 2 parentheses x minus 3, and then x squared plus 4, all of that to the third power. Okay, so here's what that graph looked like when I just pushed enter. It just looks like a straight line, but we know that that can't be accurate. Here you can either choose to look at your table first to figure out what window you should use, or just probably go to zoom like 4, and I'm going to do A for fit. Okay, so when I did zoom fit, it gave me a decent window. So you can see it looks like that. Then I'm going to press tab again to get another equation, and that's where I'm going to do 2x up arrow 7. And it's generally the same thing. So that'd be the power function related to it. Does that make sense?
Well, okay, so if you do your calculator, what does it say pointing to the 2x to the 7th power? Leading what?
Coefficient. Yeah. Leading coefficient. Yeah, so remember this too. Okay. Anything else? Yes.
Why couldn't one of the real zeros be -4 if multiplication?
That's a good question, but it's because it's imaginary. That's the easiest way for me to explain it. If we go to just x plus, or x squared plus 4 to the third power, well, that didn't show up on here. Let me do zoom fit again. That's looks like it's touching, but it's not. Okay, so to me the best way to answer that is it doesn't really cross below the, or it doesn't cross the x-axis, because at 0 it's 64, and then it's 125 on both sides, and then it'll be 512 on both sides, and so forth. Yeah, so to me that's the easiest way to explain it. Yeah, good question. Anything else about that? Okay. Okay, then on 56, this one shows x plus the square root of 3 squared and x minus 2 to the 4th. So the first thing is I wrote when it's an x-intercept, ignore the power. So we don't really care about the 2 or 4 in this step. All we do is we set each one equal to 0. So if you have x plus square root of 3 equals 0, then it's negative square root of 3. If y'all did that on the calculator, most likely you would get negative 1.73, but you need to know that that relates to negative square root of 3. And they would want that answer, not the decimal. Okay? And then x minus 2 equals 0, so x is 2. So those are your two x-intercepts, just based on the information there. And for this one, it's multiplicity 2. For this one, it's multiplicity 4. Okay, and again, since it's even, it's going to touch at both x-intercepts. Let's graph that and see what it looks like. Okay, so we have x plus square root of 3 raised to the second power, and then x minus 2 raised to the 4th. Remember, on your calculator, you got to manipulate things like go to the outside of the parentheses, and when you type the exponent 2, make sure you go to the right, so you don't have your parentheses up too high. Just little typo type things, so make sure you don't make those mistakes. So the graph looks like this, and so there's your first one. So, like for example, if you go to Analyze Graph and then Minimum, between here and here, it's going to say negative 1.73. But we don't really want that. We want negative square root of 3 because we want the exact answer. Okay. And then the other one would be 2. Question? Okay. So then, as far as the max number of turning points, what we look at is our powers. So x squared and then x to the 4th. So we ignore the little horizontal shifts. And then if we have that, that turns into x to the 6th. You don't have to put this extra writing if you don't want to. So basically, it turns into x to the 6th. And because it's 6, then it's a max of 5. So then for your power function, first step is always look back to your original. There was no coefficient in front, and so you keep it 1, bless you, and then you just put x to the 6th. So that power function is simply x to the 6th. And let's see what that looks like on the calculator after y'all are done writing. Yes. You're welcome. Okay, so the graph for x to the 6th looks like this. So that's our power function. Let me do zoom fit. 4 and then zoom fit. Okay, so when I did zoom fit, you can actually see that it looks close to what it was before. Like, you know, those two functions look pretty close to each other. Okay, any questions? Okay, so that's your power function. Now on 61 it says look at the given graph. So in this case, the given graph is this one. So we have an x-intercept at -1 and +1, and then our y-intercept is somewhere above 1, and it looks like it's going to be cubic. The reason why I know it's cubic is because I see 2 turning points. Okay, if there's 2 turning points, like one maximum, one minimum, it's going to be cubic. Okay, so it is a polynomial. Those are your x-intercepts, -1, 1, and 2. So our minimum degree is 3. And so I'd estimate that function to be x plus 1 times x minus 1 times x minus 2. Looks like you don't have to do anything beyond that for it. Minimum degree 3. The next one, okay, so this wasn't matching graphs, it's just a number of questions related to interpreting graphs. This one looks like a W. show you. That one, and it has x-intercepts at 1 and positive 2. So you don't have to draw the graph on paper, but your x-intercepts are -1 and 2. This one had 3 turning points, and so then it's degree 4. Now, the reason why we knew to put degree 4 is because of the multiplicity on both of them. So remember that if it touches or bounces, that it would have even multiplicity. So this at -1 really changes to x plus 1, and then we square it. And same thing on this one. If we have x minus 2, it's right 2, and we square it. So that's your estimate. Then if you're looking at this part, for 63, it's not a polynomial because there's a gap. And there, on 64, it's not a polynomial because there's a sharp point. Not a polynomial, gap, and then not a polynomial, sharp point. Because this last one is an absolute value function. The v is the absolute value function. Pause this for a second. Okay, so the gap is right there. It's a discontinuity at -1, and then this one's the absolute value. So neither of these are polynomials. Okay, so that was 63 and 64. Number 65. So this one crosses at 0, 1, and 2. Okay, there's the graph. It crosses at 0, 1, and 2, so those are all odd multiplicity. And so based on the 0, it's just x, or you could have put x minus 0, x plus 0, but that's extra. And then x minus 1 and x minus 2. You don't have to write this to the side. That's just hints. 0, 0, 1, 0, 2, 0, and so your real zeros. It's just extra. I'm okay with that part. Any questions on that? Okay, 66 looks like this graph, and again there are 3 points at 0, 1, and 2 is where they are. But the difference is this one crosses at 0, it bounces or touches at 1, and then crosses at 2. So your multiplicity is a little different than the one above it. So this one, we've got x, and then we've got x minus 1 squared and x minus 2. Now, if I remember right, the reason why I put this little dot here is because if you're typing it on your calculator for checking it, it may give an error. So if you don't do the little time sign. So let me double check that. Let's go to a new document. If I put x parentheses x minus 1 squared times x minus 2, it says error cannot accept change, input invalid. Okay. Okay, so if it says error cannot accept change, that means that you did a typo of some sort. Actually, let me just delete some of this stuff to make sure we do it right. X times x minus 1 squared and x minus 2. Okay, and so then you can see this graph, and that is pretty similar to this graph. All right. Okay, our next ones are at -1, 1, and 2. And why it's a little harder is you now have a y-intercept that's at 1 instead of 0. Those other two had a y-intercept of 0. So what I noticed at 67 is it crossed at -1, it bounced at 1, and it crossed at 2. So that's the basic part. So that means if it crosses, it's going to be x plus 1, and then it bounced, so it's going to be squared. Whenever it touches or bounces, it's going to be squared. So that's x minus 1 squared, and then this part's x minus 2. So that's like the start of it, but that'd be upside down. So like if you want to check your answer intermediate steps, you'd have x plus 1, x minus 1 squared, and then x minus 2. So this starts high and comes down, but on 67 it starts low and goes up. So because of that, we needed to reflect the x-axis. So all I did is I stuck a negative sign in front, and then I needed to check my y-intercept after that. So let me stick a negative sign in front. Okay, so now it's oriented right, except the problem is my y-intercept. So if I go to my table, I can see my y-intercept is 2, but I want 1. And so just my thought process was I'm going to either try -0.5 in front or -2. And the one with -0.5 worked.
So you just have to like plug in.
Yeah, plug in numbers and try. Yeah. So I put -0.5. I think the key has -0.5 as a fraction. It doesn't matter.
When we're done with this, we start doing turn it in.
Yes.
Can you move that up a little bit?
Yes. To 68. We're not completely done
Oh, I
though.
put up the video. I'm already done.
Oh, okay. You want it higher? Okay. Okay. The next one we have it crossing at -1, 1, and 2. And so those are the parts that we wanted. And we also had to reflect across the x-axis. So I made it negative. The y-intercept in the book was -1, but on the calculator was -2, and so I ended up having to put -0.5 in front, just like the previous one. So these two, to me, were probably the hardest type. I'm going to freeze it or stop right there, even though we have a little bit more, because the bell's about to ring.